Hello, today we're going to be learning about squares and square roots. Please make sure you have your notebook page set up with the title and today's date. Make sure you copy down all of the notes, and remember, when you're writing notes, the video should be paused so that you can listen when I'm speaking. All right, let's get started. Okay, so squares and square roots. So the first thing we're going to talk about is squaring a number. Okay, so when we are talking about squaring a number, we're talking about when we take a number and we multiply that number by itself. Okay, so squaring a number is multiplying the number by itself, or another way to say this is raising it to a power of 2. That means that we're using 2 as an exponent. So here are a few examples. If I have 4 squared, we call the exponent 2 squared. 4 squared is the same thing as saying 4 times 4. So we're multiplying this number by itself. Okay, 4 squared is equal to 16. I'm going to write this down at the bottom, actually. So 4 squared is the same thing as saying 4 times 4, and that's going to equal 16. Okay, so 4 squared is equal to 16. Down here we have 3 squared. 3 squared is the same thing as saying 3 times 3. We're multiplying the number by itself. 3 times 3 is 9. And the last example, we have 5 squared. We're multiplying 5 times itself. 5 times 5, that's going to equal 25. So we just took these numbers, which the 4 in this example, the 3 in this example, the 5 in this example, those are called the base. The 2 is the exponent. We're squaring it to the exponent of raising it to the exponent of 2, and that is the square. Okay? So remember that when we are looking and we're saying we're squaring a number, we're using the exponent of 2. Okay? Our exponent is going to be of 2, and we call that squaring. All right, and so next is this square root. And I'm sure you have seen before this symbol. A lot of students confuse that symbol with division. It is not a division symbol. This is called, actually it has a name, it's called a radical. And this we use to identify when we're looking for the square root of a number. So let's dig into that a little bit, okay? So when we're looking at a square root, we're actually going backwards from what we just did up top above. So a square root, we're going backwards. It is the value that is being multiplied by itself that equals the number. So let's see if I can get it all on the screen here. So in our example up here, where we did 4 squared was equal to 16. Well, if you look here now, the question being asked here is, what is the square root of 16? Well, you have to ask yourself, what number can you multiply times itself to equal 16? And we did that up here. It's 4. So the square root of 16 is going to be 4. It's going to equal 4 because 4 times 4 equals 16. Okay. And again, just like on our second example up top, 3 squared equaled 9. So if you ask yourself, what is the square root of 9? You're going to think of what number times itself will equal 9, and that's going to be 3. And the square root of 25, well, we know 5 times 5 is equal to 25. So the square root of 25 is 5. Okay? So squaring the number and finding the square root are just the inverse operations. Okay? There is something we need to think about here, though, because we do understand that with integers, when we're multiplying integers, if I multiply two negative integers, I'm going to get a positive integer. So let's take a look at how this affects square roots. Okay. So here it says that there are 2 square roots for every positive number. Okay. So there are 2 square roots for every positive number. So here's an example. The square root of 36, is going to have two answers. It's going to be 6 and -6. Because if you take 6 squared, 6 times 6 is equal to 36. But also, if I take -6 and I multiply it by a -6, I'm also going to get a positive 36. So each square root is actually going to have 2 answers. So let's go back up here where we just were for a second and include that. Because if I'm looking at this square root of 16, I know that positive 4 times positive 4 is going to equal 16, but also -4 times -4 equals 16. Same thing here with the square root of 9 is equal to a positive 3. Also, -3 times -3 will equal 9. And lastly, for the square root of 25, positive 5 times positive 5 equals 25, and -5 times -5 equals 25. I want to emphasize this now. This is only true for square roots. You're going to learn about something a little later that are called cube roots, and this does not apply. So it's specific to when we're talking about square roots, when we're multiplying a number by itself, okay? We'll discuss that further in class. Okay, so now this is going to take us into a discussion about perfect squares. So a perfect square is going to come from integers that are multiplied or whole numbers. So we're talking about the counting numbers and their opposites, okay? So a number that is a perfect square has square roots that are integers. And when I'm speaking about integers, we know that we're talking about the negative numbers like -1, -2, -3, so on and so forth. And we're talking about the positive numbers like 1, 2, 3, so on and so forth. Okay? So whole numbers and their opposites. If you square these numbers, their answers are perfect squares. So here's an example. 81, or the square root of 81, is a perfect square because its square roots are 9 and -9. So these are just whole numbers, okay? The difference here would be a non-example of this is if I have like 2.5. 2.5 is not a whole number. It's a decimal. So that, if I multiplied it by itself, would not be a perfect square. Now we're going to use perfect squares a lot in class, and I don't expect you to memorize them, but you are going to need a reference in order to be able to do them. So a good way to start learning the perfect squares is to make a quick reference guide. I want students to make this in a separate page in your notebook. So you're going to go to a separate page, the next page in your notebook, and you're going to title it Perfect Squares Quick Reference. And you're going to set it up just like this. Okay, so pause the video, set it up. Then what you're going to do, and you're going to want to get a calculator for this. You should know up until 12 squared because we know at least there are 12 timetables, right? So what you're going to do is just fill in the answer here for each one so you have a listing of the perfect squares. So remember, your perfect squares is the number multiplied by itself. So 1 times 1 is going to be equal to 1. 2 times 2 is going to be 4. 3 times 3 is going to be 9. So we're just making the list of our perfect squares. 4 squared is the same thing as saying 4 times 4, that's 16. So I'm going to let you continue on. Just remember that you're multiplying the number times itself, not times 2. Okay? And you're going to do that all the way till 20. Use a calculator, especially for the higher numbers, to make sure that you're getting the correct answer. So this will be a good reference for you to use in class. I will be checking this when I check your homework. Pause and complete that now, and then come back. We're not finished with the notes for this lesson. Okay, so now that you have your list of perfect squares, what we're going to do next, you're going to need to look at that list in order to reference that list in order to do them. This is just one example of how handy that list is going to come in, because you're going to have a lot of assignments and tasks where you need to know what the perfect squares are. I don't expect you to memorize them all, but if you have a reference, it's really helpful. So we're going to be approximating square roots. So on a number line, we should be able to place all of the square roots on a number line. Some of them are easier to find than others. So the perfect squares are easy to find because they simplify down to a whole number, like 9 or -9. But the ones in between might be more difficult to find. So we're going to approximate them. So here are the steps. Please make sure you're copying down the steps. So the first thing you're going to do, we're looking for the square root of 84. 84 is not a perfect square. There is no number, no whole number times itself that I can multiply to get 84. So I have to find the closest ones. So if you look at your list of perfect squares, what are the two perfect squares that the square root of 84 falls in between? So take a look at your list that you made. The square root of 84 you should find is between the square root of 81 and the square root of 100. Okay, so this is the process we use for estimating. You're going to write the non-perfect square in the middle and then surround it on each side by a perfect square that it would be found on the number line. The second step then is you're going to take the square root of both of the perfect squares. So remember, the perfect squares are the ones that I have in purple, the ones that come from your list. So you're going to take a look. The square root of 81, well, we've looked at that example today. That's 9. The square root of 100, that's 10. So 9 times 9 equals 81. 10 times 10 equals 100. The square root of 84 would have to be some number between 9 and 10. Now, to estimate it, we want to see, is it closer to 9 or closer to 10? So let's take a look at which one it would be closer to. 84 is much closer to 81 than it is to 100. You can do a subtraction between each one to see how far they are from each other. But between 81 and 84, there's only 3 steps. That's the closest. So the square root of 84 is going to be closer to the square root of 81, which is 9. So the way we answer these when you're doing them in class, you're going to be given a question to respond to, and they're going to ask you, the square root of 84 can be found between which two numbers? It'll be between 9 and 10 on a number line. So if you look here on this number line, here's 9 and here's 10. The square root of 84 is going to be somewhere in this vicinity between these two. And we say that it is closer to 9. So we're going to have to draw it on a number line so that it looks like it's closer to 9 than to 10. Now we're going to practice these in class. If you need to, please rewind this and watch it again. This is really important for you to understand the concept of estimating the square roots and what a perfect square is. So watch this again. If you need to, write down any questions you may have, send them to me on Remind, and we will go over this. We're going to practice this a lot in class. I'll see you soon.